6.1 radian measure. Radian, an angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle, has a measure of 1 radian. I know that sounds kind of complicated, but what they're talking about is the radius of this circle here. They're saying that if you mark off that same distance here, then you look at the angle that intercepts that arc, that's going to be an angle of 1 radian. All right. Now, notice if you drew the circle bigger, you could extend that out and say, well, here's the radius now. So if you draw that same distance, that same radius, it's still going to take up the same angle. Okay. Now, we normally are going to talk about the unit circle, so we typically only talk about the circle of radius 1, but that's what a radian is. Converting between degrees and radians. To convert to radians, multiply your degree measure by pi over 180 degrees. To convert to degrees, multiply by 180 over pi. So examples 1 and 2 are conversion problems. Convert each degree measure to radians. So if I want to go 2 radians, kind of how I remember it is if I want radians, I want pi. And it looks like I want to cancel out degrees, so just look at your units. We're going to put 180 degrees on the bottom so we can cancel out the degrees. What's going to happen is we need to reduce a fraction, and so probably the best thing to do is say 45 goes into 180 4 times. So this fraction reduces to pi over 4. That is pi over 4 radians. But it's kind of weird, when your units are radians, you don't really have to have the units. Everything else you need units. For degrees, for inches, meters, feet, seconds, whatever. You always need units, unless it's radians. Part B, negative 270 degrees. We're going to convert to radians, so we're going to do that same conversion, times pi over 180. So probably the best thing that you can do is reduce a fraction. I can see that 90 goes into 270 3 times and into 180 twice. So reducing that fraction, you're going to get negative 3 pi over 2. Next one, 249.8 degrees. You're still going to do the same conversion, times pi over 180. But in general, here's what you'll do. If you see a decimal in the problem, get out your calculator because you're going to have a decimal in the answer. So if I've got a decimal in my problem, I'm just going to type it in, okay? So go ahead and type that in on your calculator, 249.8 times pi over 180. Make sure you enter the pi button. Don't use 3.14. That's been rounded off. So if I do 249.8 times pi over 180, try it yourself, you get about 4.360, somewhere in that ballpark. So now let's convert to degrees. How I remember it is I know I want to cancel out that pi. That helps me to remember that it's going to be 180 over pi. The pi is just going to cancel. I'm still trying to reduce a fraction. If you use a calculator, that's fine. 9 times 180 divided by 4, hopefully that comes out right. If you don't have a calculator, you reduce. 4 goes into 180 45 times. 9 times 45, I'm using a calculator for that. 9 times 45, you get 405 degrees. Make sure to use your units. The only time you don't need units is if it's radians. If it's degrees, you have to have the units. If it's degrees and you don't put degrees, it's going to be assumed that you mean radians. Make sure you don't do that. Part B, negative 5 pi over 6. We want degrees, so we're going to multiply by 180 over pi. We know the pi is going to cancel. 6 goes into 180 30 times. So it turns into 5 times 30. You're going to get negative 150 degrees. 4.25, same conversion. We're going to degrees, so we multiply by 180 over pi. And again, here's the general rule. If you see a decimal, give me a decimal. 4.25 times 180 over pi on a calculator is about 243.5 degrees. find each function value. We want to do tangent 2 pi over 3, okay? So when we look at the chart, let me see. It should be really clear really quickly that we're going to be looking at a pi over 3, okay? It just has to do with common denominators, but as soon as I see pi over 3 in the problem, I'm pretty sure I'm using pi over 3 in the chart. And that's why this is going to be faster than if you're using degrees. So you can like immediately tell that this is going to be a pi over 3 reference. All right, so the thing is, if I wanted to do tangent pi over 3, I'm going to do sine over cosine. And the thing that's hard, I guess, is you're going to have to tell me where it is, so you'll know if this thing is going to be positive or negative. Okay, so let's think about where this thing would be. Okay, I told you to memorize. Over here is pi, and over here is 2 pi. Resist the urge to call that 180 degrees and 360 degrees. We are in radians. We're using pi and 2 pi. Get a common denominator. So in this case, that denominator is going to be 3. I would call this 3 pi over 3, and over here, that would be 6 pi over 3. Notice I'm still equal to pi and 2 pi. I just unreduced it, so I have a common denominator that I can compare. Here's how easy this is going to be. We need to go around to 2 pi over 3. So if you think about it, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3 goes all the way around. I don't need to do all that. I don't need all those markings. I just need to go to 2 pi over 3. And so what you're going to do is you're going to say, well, I know 2 comes right before 3. So that puts me right there in the second quadrant. Okay? So what do I know about tangent in the second quadrant? Tangent is what? Negative. So I know that this problem is going to be negative whatever tangent pi over 3 is. So for tangent, remember tangent is sine over cosine. If you divided, oops, not that one. If you divided sine over cosine, the 2's are going to cancel out, and you're going to get the square root of 3. So it's going to be negative square root of 3. So it's going to be tempting. Somebody's going to say, well, can I just convert 2 pi over 3 into degrees, and I'll figure out that that's 120 degrees, and then can I just do what I did last chapter? Yes, you can do that, but I'm telling you right now you don't want to, because that's going to take more time. Once you figure out how to do radians, it's going to be really quick. Okay, so let's look at the next one. Sine 3 pi over 2. It should be really fast. I'm going to move this chart down here. You should be able to see really quickly that this is going to be a pi over 2 reference. Okay. This is a pi over 2 reference. All right. So if you look at sine pi over 2, we're obviously looking right here. Okay. We just don't know if it's 1 or negative 1 yet. And that's why we have to think about the location. So I told you to memorize that 3 pi over 2 is down here. So my angle puts us downstairs. And what do we know about sine when we're downstairs? It's negative. So this answer is going to be negative whatever sine pi over 2 is. So that means we're going to be negative 1. I don't need to change that to degrees. I don't want to change that to degrees. It's going to take too much time. The next one, you can see very quickly that this is a pi over 3 reference. So we know we're looking at this in the chart. If I did cosine pi over 3, I'm going to get 1/2. I just don't know if it's negative. I have to look at where we are so I know if we're negative. And so, think about what we do. I know this is pi and 2 pi. I want to get a common denominator, so I'm going to call this 3 pi over 3 and 6 pi over 3. I do this pretty much every time. All right. Now notice the negative doesn't necessarily mean our answer is negative. It means we go around backwards. And so if I go around backwards, you'd have to think this. If I go around backwards, here's negative 3, and negative 4 is just past that. I know that I am in the second quadrant. And what do you know about cosine in the second quadrant? is negative. And so our answer is going to be negative whatever cosine pi over 3 is. So it's going to be negative 1/2. Let's do a few more. Okay, cosine pi over 6. I know that's a pi over 6. Okay, that's a pi over 6 reference. So look at where we are. If this is pi and this is 2 pi, get a common denominator. Okay, 6 pi over 6, that equals pi. And 12 pi over 6, that equals 2 pi. All I do is get a common denominator, and then I would say, okay, if I'm going around here, I don't have to go 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. I don't have to do all that to know that 7 is just past 6. I am in the third quadrant. And what is cosine in the third quadrant? So we are negative whatever cosine pi over 6 is. So we can look at the chart again and see that cosine pi over 6 is putting us right here. So it's got to be negative square root of 3 over 2. Okay. Next one. Sine 3 pi over 4. Okay, we can see really quickly that's a pi over 4 reference. So if I consider where that is, this is pi, this is 2 pi. Give it a common denominator, 4 pi over 4 and 8 pi over 4. 3 pi over 4 is going to be right before I get to 4 pi over 4. I'm in the second quadrant. And what do I know about sine in the second quadrant? It's positive. So we're going to have positive whatever sine pi over 4 is. Sine pi over 4 is this. It's going to be positive square root of 2 over 2. So if we look at the next one, cosine 5 pi over 3. Cosine 5 pi over 3. That has a reference angle of pi over 3. And then we look at where we're at. We always do this. Get a common denominator. Over 3, I would call this 3 pi over 3 and 6 pi over 3. So 5 pi over 3 is right before 6 pi over 3. We are in the fourth quadrant. So I know cosine is positive there. So we would be looking at positive whatever cosine pi over 3 is. Cosine pi over 3 is this. So we are positive 1/2. So then the last one, sine 11 pi over 6. I know that's a pi over 6 reference. So then when I graph it, that's pi, that's 2 pi. Get a common denominator. We'll call this 6 pi over 6. We'll call this 12 pi over 6. 11 is right before 12, so I know I'm in the fourth quadrant. So sine is negative there. We're going to get negative whatever sine pi over 6 is. Sine pi over 6, right there, we're going to have negative 1/2. Sine 11 pi over 6 equals negative 1/2.